Today, we're going to dive into a truly monumental shift happening right under our noses, at the very foundation of our connected world. You see, the entire telecommunications industry is on this epic journey. It's moving away from a long, long legacy of complicated hardware and, brittle handwritten scripts, and it's heading towards a future built on modern cloud-native principles. Now, this isn't just about plugging in some new tech. It's a fundamental change in philosophy, in culture, and really in how people work together to build the networks we all depend on every single day. It's the story of how a traditional telco becomes a modern techco. So we've broken this whole explainer down into a 5-act story. First, we'll start with a crumbling legacy, where we'll really dig into the problems that basically forced the industry's hand. Then in Act 2, the Declarative Revolution, we're going to uncover the new philosophy that lights the way forward. In Act 3, Forging the Cloud Native Toolkit, we'll get to meet the awesome open source tools being built to tackle these huge challenges. Act 4, the last mile networking, is all about conquering that final super tough technical hurdle. And we'll wrap it all up with rebuilding the tower together and see how this whole transformation is at its heart about people and collaboration. All right, let's kick things off with Act 1. Because to really get where the industry is going, you first have to understand where it's coming from. We're starting our story in the, let's call it, pre-cloud native era of telecom. This was a world that was just groaning under the weight of its own complexity, where it felt like the very foundations were starting to crack. This quote here from Guillaume Nivicato, an engineer at Orange, just nails the human side of this problem perfectly. Just try to imagine it for a second. You're responsible for hundreds of different sites out in the real world. Your team is great, they're super experienced, but all the critical knowledge, it isn't written down anywhere. It's just oral tradition. Bob remembers why that server needs a special setting. Maria remembers a workaround she did 6 months ago on a different site. This isn't a system you can rely on. It's just a patchwork of memories. So, like Guillaume asks, how on earth can you guarantee that what you've deployed is coherent across the board? The honest answer? You can't. And if you want to put a number on that oral tradition, check this out. The team at Orange was maintaining 20,000 lines of imperative Ansible code. And that was just to manage the lifecycle of a single service, their content delivery network. Now, imperative code is basically a very, very long recipe. It says, do this, then do that, then check on this other thing. So what happens if step, 12,501 fails? The whole process is incredibly fragile, it's slow, and it is just asking for errors. Now try to imagine scaling that approach across dozens of services. It's a complete operational nightmare, and it basically grinds innovation to a halt. So here you have the two worlds just colliding. On the left, that's the legacy telco way, those step-by-step imperative scripts and proprietary tools from vendors that lock you in. You end up with these supplier tech silos, islands of technology that can't talk to each other, making everything expensive and insanely complex. But on the right side, that's the new way. It's a declarative GitOps-based approach. It's built on open standards from groups like the Cloud Native Computing Foundation or CNCF, and instead of writing a recipe, you just describe the end state you want, and you let the system figure out how to make it happen. And here's the real kicker. The root cause was never a lack of technology. There were tons of tools out there. The real crisis was this fundamental lack of common understanding. You know the old story of the Tower of Babel? The whole project failed because suddenly everyone started speaking different languages? Well, that's a perfect metaphor for what was happening in the telco world. You had vendors, infrastructure teams, and operators all speaking different technical languages, using different data models, different APIs. All this chaos was a direct result of not having that common ground to stand on. So, with the problem clearly laid out, Act 2 is all about the big philosophical shift that provides the solution. We're talking about a whole new way of thinking, moving away from giving those step-by-step imperative commands and moving towards just expressing your high-level declarative intent. And the bedrock of this new common language is something called the Kubernetes Resource Model, or KRM. So if the old world was the Tower of Babel, think of KRM as the universal grammar for the cloud-native world. It gives us a single, uniform way to describe any piece of configuration as a standard resource. But the real magic comes from custom resource definitions, or CRDs. They let us teach the Kubernetes API about anything. It could be an IP address, a VLAN, a 5G network function, you name it. Each one becomes a first-class citizen in the system, managed with the same consistent, declarative API. This whole claim model thing is how we make that abstract idea real. Let's walk through it with an example we can all relate to: asking for some storage. So a developer is defining their application in Git. They simply state their intent. Hey, I need 1 gigabyte of storage. That's it. They don't say how to get it or where it comes from. Then the Kubernetes stateful set controller sees that intent and creates an object called a persistent volume claim. Next, another specialist controller sees that claim, talks to the actual storage system in the background, carves out that volume, and makes it available. And boom, the application pod starts up with the storage attached. The developer's simple, high-level intent was fulfilled by a chain of smart, autonomous controllers. So how does this new way really stack up against traditional GitOps? Well, in the traditional model, Git is the one and only source of truth. That means every single little detail for thousands of different sites has to be spelled out explicitly. But when you combine GitOps with KRM, the source of truth gets shared. Git holds the high-level intent, the what, and Kubernetes manages the dynamic, low-level state, the how. So, for example, Git just says, I need an IP address. Kubernetes is the one that actually records which specific IP was assigned. This creates a much higher level of abstraction, which gives you a ton of flexibility and makes the whole system so much easier to scale. Okay, so now we get the why and the what. Let's dive in to the how. In Act 3, we're going to check out the amazing open source tools being built to make this new model a reality. You can think of these as the actual building blocks for our new tower. First up, we've got a tool called Porch. This thing was actually born inside Google to solve their own, massive scaling problems. Then they donated it to the open source Nefio project. Its entire reason for being is to answer that key question for telcos. How in the world do you manage configurations for not just a few clusters, but for thousands, maybe even tens of thousands of them? Porch is literally built from the ground up to handle that kind of extreme scale. A really cool concept in Porch is called fan-out. The idea is you start with a single generic blueprint package, sort of a master template for a service. Fan-out is the automated process of taking that one blueprint and using it to crank out thousands of unique, fully configured deployment packages, one for every single cell site or cluster. They're all similar, but each one has the specific little details that make it ready for its unique destination. And hydration is the magic that makes fan-out possible. It's how you go from DRY to WET. The first blueprint is DRY, which stands for Don't Repeat Yourself. It's clean, it's generic, it's efficient. The hydration process then comes along and mixes in all the specific data from user input, from other automation systems, and it produces a wet deployment package. And wet stands for Write Everything Typed Out. It's completely specified, every detail's written out, and it is ready to ship. Next up, from the team over at Swisscom, we have the Netbox operator. So while Porch is busy managing software packages, this tool is all about managing network resources. Netbox is a super popular open source tool. It's a source of truth for network automation. It's where you keep track of all your IP addresses and VLANs. The Netbox operator lets an application running inside Kubernetes simply claim an IP address using that same declarative model we just talked about. The operator sees the claim, gets an address from Netbox, and fulfills the request. It perfectly integrates all those critical network resources right into the cloud-native workflow. And the results of this new way of thinking, they are nothing short of dramatic. Look at this. At Swisscom, network provisioning, a process that used to take up to 10 days of manual work, is now down to just 2 hours. And even more amazing, network validation, which used to take 5 full days of manual checks, is now done in 5 minutes. This isn't just a small improvement. This is a complete game changer in what's possible. This is what moving from a telco to a techco actually looks like in practice. You know, every great journey has that one last, really tough peak to climb. In our story of telco transformation, that final peak is networking. For years, one of the most notoriously difficult problems in the whole Kubernetes ecosystem has been trying to attach multiple separate network interfaces to a single pod. And for telco workloads, this isn't some niche nice-to-have feature. It's an absolute must-have. And let me tell you, solving this was not easy. This timeline of Kubernetes enhancement proposals, or KEPs, shows that this was a multi-year effort. You can see KEPs being proposed, debated, and even closed down. Not because they were bad ideas, but because the community was so committed to finding a solution that was not only powerful, but truly native to the way Kubernetes is designed. The fact that KEP 4117 was finally accepted and is moving forward shows that all that collaborative struggle is finally paying off. For a while, the community's workaround solution was this thing called a network attachment definition, or NAD. But just look at the code here for a second. You can see the problem right away. The main configuration, it's not a real structured Kubernetes object. It's just a big blob of JSON text that's been jammed inside a YAML string. I mean, it was a clever hack that solved an immediate problem, but it was fundamentally not a native solution. You couldn't validate it properly or manage it with standard tools. It was messy. Now compare that to the new native approach. It's built on a feature called Dynamic Resource Allocation, or DRA, and it is a world of difference. Just look how clean and elegant this is. Instead of that messy JSON blob, a pod now makes a native resource claims request, right there in its own spec. It can ask for a network interface in the exact same way it would ask for a GPU. The network finally becomes a first-class claimable resource inside Kubernetes. This is the integrated, sustainable, and frankly, the right way forward.
And that brings us to our final act, where we get to what I think is the most critical ingredient of all. We've seen the tech, we've seen the philosophy, but this transformation isn't really about code or APIs. At the end of the day, it's about community, it's about collaboration, it's about people.
To rebuild that tower, you absolutely need a common language. And this proposal from Deutsche Telekom for a component manifest is a perfect example of what that language looks like. It's a single, machine-readable file that describes everything another tool or team needs to know to use a component. It spells out its identity, its configuration rules, what other things it depends on, how to talk to it, and even what metrics it gives off for things like energy efficiency. This manifest is like the Rosetta Stone that lets all the different pieces of the puzzle actually understand each other. And what's really amazing is that no single company, no matter how big they are, could ever solve this problem alone. This whole transformation is being powered by this vibrant, interconnected ecosystem of open source projects. You've got Silva, where 29 different companies are working together on a telco cloud stack. CNTI is harmonizing best practices, Nefio is tackling that massive automation challenge, and Kamara is defining developer-friendly APIs. You have operators, vendors, and cloud providers all sitting at the same virtual table, building these common tools together. So this all brings us to one final, really crucial question. The technology is moving forward at an incredible pace. We have the declarative models, we have the automation tools, we have the native APIs, all the building blocks are here. But the ultimate success of this entire journey, it doesn't hinge on the next software release or the next KEP. It hinges on the ability of this global community to keep collaborating, to keep communicating, and to keep building with a truly shared vision. The tower is being rebuilt brick by brick together. Thanks for joining this explainer.